Hi everyone, and welcome to Unit 6, Lesson 3, Acute Angle Trigonometry. So this is actually going to be the last new lesson of the summer course, so we're almost there. Okay, learning goals. You're going to be using something called the sine law and something called the cosine law to solve triangles. In other words, figure out missing sides, figure out missing angles, and we're going to combine this with what you learned in the previous lesson. So SOHCAHTOA, as well as the Pythagorean theorem. So you have a whole bunch of tools you can use to find angles in triangles. And what you're going to have to do is figure out which of those methods works with the problem that you're given. Okay, so once you figure it out, you're going to use sine law and cosine law to solve triangles. So you could use these other techniques sometimes as well, but we've covered these ones before. So now we're going to cover these ones, as well as solving some word problems. Okay, so first thing to know, whenever you have a right angle triangle, to find a missing side or angle, there are generally two tools that you're going to use. So this should be stuff that you already know. If you have two sides in a right angle triangle, you can get the third side using the Pythagorean theorem. If you have a side and an angle, then you can get another side using SOHCAHTOA. If you got a couple sides, you can get an angle using SOHCAHTOA as well. But what if you don't have a right angle triangle? Because remember we said last lesson that SOHCAHTOA doesn't work unless the triangle is a right angle triangle. So what if you don't have a right angle triangle? What if it's a different kind of triangle? So there's no right angles in it. Well, there's two other tools that we can use that we're going to introduce. The first one's called the sine law, which is written sometimes like this: A over sine A equals B over sine B equals C over sine C. You'll also sometimes see it written this way. Because these are ratios, it really doesn't matter which one you use. Both of them are correct. Okay, and we'll talk about how that relates to this triangle in a little bit. Cosine law, there are several different variations of it, but essentially what the cosine law says is that you have some side. Let's just say you're looking for side C. Then to find side C, you do the other two sides squared, add them together. So it actually comes from the Pythagorean theorem, which you can maybe see. And then subtract 2 times both of those sides together times the cosine of the angle in between those two sides. So that's the cosine law. Okay, and you'll see that there's 3 different versions of it, but really they're the same, right? It's always just if you want any side, then the square of that side is the sum of the squares of the opposite sides minus 2 times the opposite sides times the cos of that angle. Okay, so the formula works the same way every time. That might be hard to understand the way I just said it, but if you try out the questions, I think that'll become obvious to you once you've done enough of them, because you're going to see that you keep following the same pattern with the triangle every time you do it. Okay, so there are proofs for both of these laws. They're not magic. They're in your textbook, but we won't be covering them in this course. You don't need to know them for the test. You don't need to know them for the exam. We can just assume that they're there and you can just use them. Okay, but before we can start solving these problems, there are 2 things that you need to know. You need to know how to label these triangles, which might seem easy, and it actually is easy, but if you don't know this process, it might seem a little weird. And then you have to know which method are you using. So I'm giving you all these formulas. How do you know which one to use? So once you know those 2 things, then you'll be able to apply the formula as needed. So first things first, how to label triangles. So let's just say you have a triangle A, B, and C. So you label your angles with capital letters. And then often we give these sides lowercase letters. And the way that this works is the angle matches up with the side opposite to it. So if this angle is capital A, this side is lowercase a. If this is capital C, this side is lowercase c. It's always opposite. One way you could think about it is whatever letters you have in a triangle, A, B, C, D, E, F, whatever you want to call it. If this is angle A and this is angle B, then the side here is going to be the one letter that you don't see on this side, right? So there are 3 letters. There's A, there's B, there's C. On this side, you have A and you have B. What's missing is C, so you put that in there. Okay? So that's labeling triangles. Hopefully pretty easy. The next thing you need to know is what method are you going to use to solve the problem that you have in front of you? So to be honest, I think unless you're really familiar with it, this is one of the harder parts of doing this. And this is why you need a lot of practice at it. So there's this handy little flow chart that will kind of guide you through what to do, but unless you know what to look for, this might just be gibberish. So it's really important that you practice. And like, I can have this in front of you if you want during the test or the exam, right? I mean, it might be useful to make sure that you make the right decisions. Okay, so to start, you look at their triangle. You want to try and find missing sides or missing angles in it. The first thing you want to ask yourself is it a right angle triangle? If the answer is yes, then you're going to have an easy time with it because there's only two options. You can use SOHCAHTOA or you can use the Pythagorean theorem. So does the question involve any angles? So if you have any angles at all that you need to input into your solution, you're going to use some kind of SOHCAHTOA. If you don't have angles, that means you only have sides. It means you have two sides and you're looking for the third side. So that's going to be c squared equals a squared plus b squared. So that's if it's a right angle triangle. What if it's not? What if it's not a right angle triangle? Then you're going to use either the sine rule or the sine law, as it's called, or you're going to use the cosine law, which we just briefly kind of mentioned. So how do you know which one to use? So it's kind of easier, I think, to see if you're using the cosine law. Because the cosine law really just comes from two cases. And this case is really obvious. And if you think about this case, it's not that hard to understand. So it's when you have three sides. So you don't have a right angle triangle, but you have three sides. And you want to find an angle of some kind. If you have three sides, you're doing the cosine law. The other case is, let's look at this as an example. Suppose you had side C and you had side A, and you also had angle B in between them. If you have that case, as we call it, side, angle, side, then you're also doing the cosine law. You could think about, like, both of these cases go with similar triangles. Like that. Remember how to prove a triangle is similar? You can use all three sides, or you can use two sides and the angle between them. Cosine law matches that. So whenever you have all three sides and you're looking for an angle, or when you have two sides and the angle between them, you're using the cosine law. And again, that's when the triangle is not a right triangle. Any other case, when you have a triangle that's not a right triangle, and you're going to be using the sine law. So the second you see two angles, you know you're using the sine law. If you have two sides and an angle, but the angle is not in between the sides that you have, then you're using the sine law as well. Okay, but you don't even need to remember this, to be honest. If you just remember cosine law and you say, oh, it's not those cases, it's not three sides, it's not side, angle, side, but it is a triangle that's not a right triangle, then you know you're over here. Okay, let's do some questions. Example 1. So we have a word problem here. So a bicycle path forms a 66-degree angle with one lock of a canal. I don't know if you know what locks and canals are. Not really super important, I guess, but these are like boats trying to make their way on waterways that are usually artificial. You might have heard of the Welland Canal. There's a bunch of famous canals in the world. Suez Canal, Panama Canal. Anyway, it doesn't matter. We have this diagram here. So 66-degree angle, 2.5 kilometer here. We want to find, let's see, so bicycle path would form a 66-degree angle with one lock, so that's lock 1. Distance of 2.5 kilometers along the bicycle path, so there we have some kind of bicycle path. The angle separating this lock from the next two locks, from the next lock, is 52. So, okay, so we have some bicycle path coming away from lock 1, and then when you go 2.5 kilometers down the path, you can look at lock number 2, and the angle from the path to where you're looking is 52 degrees. How far apart are the two locks to the nearest tenth of a kilometer? So you can imagine maybe doing this calculation, maybe. If you know that you started out here and you know you walked 2.5 kilometers, if you can get the angle from yourself to where the next lock is, you can actually figure out how long that is. So this is where this stuff actually kind of becomes useful in certain cases, because you can find out, for example, how tall buildings are just by making easy measurements, or find these kinds of distances even when you're not actually physically there. Okay, so we have our triangle. Let's draw it out so it's a little bit easier to follow. And we want to find how far apart are the two locks. So we want to find the distance from L1 to L2, which we have here as L and K. So we want to find this distance. Okay, I just kind of showed there what you're supposed to do, but let's think about this through our flow chart, right? Is this a right angle triangle? No. So that means that you have to use either the sine law or the cosine law. Do you have three sides? No. Do you have two sides and an angle between them? Well, no, I only have one side. So that means I'm not doing the cosine law. So I'm going to be left with the sine law. So this is a sine law problem. So now that I know that, I have to figure out how I'm going to apply the sine law. So to do the sine law, what you need are three numbers and an unknown. And it might look like we have this here, but we actually don't have the right three numbers. What you need is the angle and the side opposite the angle, right? Remember that if we look at the sine law, it's A over sine A. And remember that the side A is opposite of angle A. So you need angle and opposite side pairs. Okay, so if I look at this, I have 52 degrees is paired with P, my unknown, so that's good. I need something like that. But the only other side I have is this one, and that's paired with, well, there's nothing there. So to do the sine law, I need this angle. So we're going to find that one first. Pretty easy, right? All angles in a triangle add up to 180 degrees. So 180 minus those two is going to give me what's left over. So we do that and we get 62 degrees. So now we're going to be doing the side divided by, now that I know this angle, the sine of that angle, right? Opposite pairs. So this divided by the sine of that is equal to this divided by the sine of that. Now you might be wondering, if you look at the sine law, you'll see that it comes in three pieces. But notice there are two equal signs. And what this means is you don't actually need all three pieces of the sine law. You will, at any given point, you're only going to be using two pieces. So if you have A and C, you'll be using A equals A over sine A equals C over sine C. If you have A and B, you'll be using that pair. If you have B and C, you'll be using that pair. And of course, you might replace these letters with other things as we do in this problem. Okay, so you're only using two parts at any given point. So we have this side and that angle, which we know is 62 degrees, and we have this side and that angle, which is 52 degrees, and this side is unknown. So we plug all that in, right? So P over sine P equals K over sine K, and we have three of those things. So now we're just going to be able to work this out. So here I have sine of 52 on the denominator. I want to get rid of it, so I multiply both sides by sine of 52. And they just have left doing this until the end because sine of 62 and sine of 52 are not nice numbers. And so to make it more exact, they haven't calculated them yet because they don't want to round again and again and again. They only want to round once. So that's what they're going to do. So now that sine 52 is on this side, 2.5 divided by sine 62. Remember to do sine 62 before you do 2.5 divided by that, and then multiply by the sine of 52. And you get an approximate answer of 2.2. Again, that's going to be approximate. So sine of 52 and sine of most numbers is going to be a long irrational number, so you have to round it. Okay, it is a word problem, so we have a statement there. So the distance between the two locks is 2.2 kilometers. Next question. We have some acute triangle TUV, where TU is 11 centimeters, or 11.1 rather, UV is 5.8, and angle T is 31. Find measure of angle V to the nearest degree. Okay, I would never even attempt a problem like this without drawing a picture. So make sure you draw the picture. TUV, doesn't matter where you put T, V, and U, put them anywhere you like in some kind of triangle that you're drawing on a page, and then just make sure that these things are approximate. So, okay, TU. So TU is going to be longer than UV. You don't have to draw it necessarily that precisely, but that side should be longer than that side. And then angle T is approximately 31 degrees. So you measure something there that's like 45 would be halfway between 90, so it's something less than halfway, and draw that. So it doesn't have to be necessarily that precise, but you should get an idea of what's going on in this problem. Okay, so we want to find angle V to the nearest degree. So supposing you don't know what to do here right away, go to the flow chart. Is this a 90-degree triangle? No, it's not. So you're not doing SOHCAHTOA. That means you got either sine law or cosine law. Remember, cosine law is when you have three sides, which you don't have here, or when you have two sides and an angle between them. We do have these two sides, but we don't have the angle between them. Instead, we have another angle over here. So that means it's not cosine law. So we're doing the sine law. Okay, so we're looking for sides and angle pairs. So we have the side opposite the angle. So that's good. We have a pair there. and we want v. So we have this side and we need the pair there. So this is good. We actually don't need to do any extra work because there are 4 things when you compute the sine law. If you have 3 of them, then you can do the calculation, right? Because that'll leave you with just 1 unknown. Okay, so 5.8 goes with sine of 31. So they've put sine on top this time. Again, it doesn't matter. You can put sine of 31 on the bottom and 5.8 on the top if you like, as long as you're consistent over here. So sine of 31 divided by 5.8 is equal to sine of v divided by 11.1. Okay, we want to isolate v, so we're going to multiply both sides by 11.1 to get rid of the 11.1. And we get sine of v is equal to 11.1 times this whole thing, which they haven't bothered to work out yet. They're going to leave it until the end. Okay, so probably at this point, it does make sense to simplify it. I mean, technically you don't have to, but it's going to be really messy if you don't. So they do 11.1 times sine of 31 and then divide by 5.8 to get some number that they're just leaving. They'll round it, I guess, at the end, but they're just leaving it like this for now because we're not at the final answer. So now look at what we got, right? We got sine of v on the left side and we got 0.956 over here, or 0.9856 over here rather. We want to get rid of this sign because we just want v by itself. How do we do that? Well, remember, right, if you want to get rid of a sine, a tan, or a cosine, or if you want to think about it as taking that sign and bringing it to the other side, then you have to undo it, and that becomes an arc sine with a -1. So arc sine of 0.9856, which you can do on your calculator, is 80 degrees, approximately. Okay, so hopefully that's pretty straightforward. We just got, I think, 2 more problems here. Okay. Example 3. So a boat is sailing north through a narrow section, through a narrow strait rather. So narrow body of water. And through one particular narrow section, a lighthouse marks the western shoreline. So we got a lighthouse there. Well, a buoy, some people say that buoy, is kind of a thing there, but whatever. Buoy? Some people say buoy. I don't know. There's a thing. I watched a video on YouTube. But anyway, so whatever that thing, however you say that, is here. So that's the strait in between. So what is the width of the strait to the nearest kilometer? And they give you the extra information here. So that's 4.2 kilometers from the boat to the lighthouse, 4.5 to the buoy or buoy, however you want to pronounce that, and 26 degrees in between those distances. So you want to figure out what's that distance. Okay, not a right angle triangle, so we're not using SOHCAHTOA or Pythagorean theorem. So we got sine law or cosine law. We don't have 3 sides. So we're checking to see if we can use the cosine law, right? So we don't have 3 sides. So the only other case that we use the cosine law is if you have 2 sides and an angle between them. And that is actually what we have here, right? 2 sides and an angle between them. So we are going to be doing the cosine law for this problem. Okay, so they've kind of simplified it here, but you can, like, for this problem, it's probably easy enough to look at this picture. Okay? Cosine law. So the way cosine law works is you have a side opposite an angle. If you're trying to find a side, you're going to find the side opposite your angle, and that side squared. So you'll notice that there are like 3 different versions of the formula, which can confuse people and throw people off. There we go, 3 different versions of the formula. You don't necessarily even really need to know this. All of these work the same way, which I kind of hinted at before, but it was maybe a little confusing. Let's see if we actually go through a problem, if we can see why all these are kind of the same. Okay, going down. So the formula is b squared equals r squared plus h squared minus 2rh cos b. So how do you know where to put all these letters? Well, you got the case where you got 2 sides and an angle in between them. So what's always going to happen is you're going to get the opposite side squared. That's going to go on the left. Whether this is A, B, or C, doesn't matter. That thing's going to go on the left, is equal to this squared plus this squared times let's start over. All right, so you're going to have the side opposite the angle. So that side squared goes by itself on the left, is equal to this squared plus this squared. And again, it doesn't matter what your letters are, right? A, B, C, doesn't matter. It's always, if you have the angle, the sides opposite the angle squared is equal to this side squared plus this side squared minus 2 times this times this times the cosine of this. Okay, so you don't even really, to be honest, I don't memorize that formula. I know that it's the kind of parts of it, right? I know it's something squared equals something squared plus something squared minus 2a minus 2 times something something cosine of something. But I don't remember the actual letters. What I just remember is the position of everything. So the opposite side squared is equal to the sum of the other two sides squared minus 2 times those two sides, cosine the angle in between. Okay, so you just plug everything in. It's kind of annoying, but it's just some algebra to do here. So square this, add them together, subtract all of these things multiplied together. And remember, that doesn't give you b, that gives you b squared. So you got to take the square root of both sides. And that gives you the answer, which is approximately 2. Okay, next question, example 4. So we have runners in a 10K race follow a triangular course, and the 3 legs of the race in order are 3.8 kilometers, 2.4 kilometers, and 3.8 kilometers. Find the angle between the legs in each pair to the nearest degree. So we're trying to find the angle between all of these legs. So you're trying to find 3 angles, essentially. You're trying to solve the triangle. Find all the sides and all the angles, because you already have all the sides. So I would draw a picture of this. So again, you have a kind of limited amount of information to work here. You don't really know what these angles are, so your picture might not really look like this. But as long as you got 3.8, 2.4, and 3.8, you're good. Okay, so, and you have A, B, C, so that you know where everything goes. So I guess the race runs like this. So from here to here to here to there. Okay, so we don't have a right angle triangle, so we're not using SOHCAHTOA or Pythagorean theorem. We are looking at either sine law or cosine law, so we'll see, are we using the cosine law? Well, remember, cosine law is used if you have 3 sides, and well, look at that, we got 3 sides. So we're going to be doing the cosine law here. So what do we want to find? We'll pick an angle that we want. So in here they're doing B. So let's try to find angle B. And again, remember how this formula works. You don't have to memorize or try to get confused with letters. Let's just go with how this formula works. So I want to find this angle. So remember that this angle is associated with the opposite side. So the opposite side squared is equal to this squared plus this squared minus 2 times this cosine of this. Right? The thing that's by itself is opposite the angle that you're concerned with. So if you had this angle and you were trying to find this side, you would do this squared equals this squared plus this squared minus this, minus 2 times this cosine of this. So you're going to use that same formula, except now what you have on the left side there, that 3.8, is actually filled in, and the angle is unknown. Okay, so one of the ways that you can do that, so there's a few ways you can do this. The way that they've done it here is they've done just what I've sort of mentioned, and they've given you that formula, and then they've rearranged the formula to solve for cos B. So they've subtracted a squared and subtracted c squared. They've brought all that over to this side. And then to isolate cos B, you divide by negative 2ac. So, right, you bring the a over, you bring the c over, so you get b squared minus a squared minus c squared is equal to negative 2ac cos B. You want to get rid of the negative 2ac, so you divide by negative 2ac. If you want, you can do it that way. If you find that a little bit confusing, what you can do is plug in the numbers first, and then that'll allow you to simplify this part and simplify this to one number times cos B, and you can move everything after that. Doesn't matter. Either way will work. So they've rearranged the formula, and you now have cosine B. So then they plug in the numbers. Again, if that's the angle that you're looking for, then the first thing in there, the thing that was by itself, is going to be the opposite side squared. Subtract the other two sides squareds. And then you divide by negative 2 times these two sides again. Okay, so that gives us cos B is equal to this. And we want to undo the cos. So we use arc cos, and that gives us angle B. So angle B is 72 degrees. Okay, so hopefully that's not too bad. We now have an angle in there. So we need to find all 3 angles, and we now have angle B is 72. So how do we get angle C and angle A? Well, now you get a little bit of choice. because you could do the same thing again. You could use the cosine law to get angle C with this is the opposite side. And you could do the same thing to get angle A with this is the opposite side. But now that you got an angle in there, you could use the sine law because you have this side opposite that angle and this side opposite this angle. You could find this angle that way, for example. So let's see what we got here. Excuse me. So we've got, they're going to choose to use the sine law. So again, this is what we have so far. So they're going to look for angle C. And so we got 3.8 opposite the 72 and 3.8 opposite angle C. You might notice something here. You don't even really need to do this calculation, but let's do it, and then we'll talk about why you could, well, I guess they show it here. Okay, so sine of C over 3.8 is equal to sine of 72 over 3.8. Do some algebra, multiply both sides by 3.8 to get rid of the 3.8 over here. So we get sine of C is equal to 3.8 times sine 72 divided by 3.8. So we've got sine of C is equal to sine of 72. So you might just notice that that and that are the same. And, well, sine of 72 is equal to sine of something. What do you think will go there? Well, it's going to be 72, right? Because these sides have to be the same. There's no other number that works here. Sine of 68 doesn't equal sine of 72. Sine of 72 equals sine of 72. So we know that angle C is equal to 72. Okay. So they're the same. And you didn't actually have to use the sine law to figure that out because it's an isosceles triangle, right? Remember that those two angles will be the same in an isosceles triangle. The angles that are not touching the opposite side of an isosceles triangle are going to be the same. So that's 72. So now that we have both angles of the triangle, we can get the third one very easily. We don't need, you could use sine law or cosine law, but you could also just do, if this is 72 and that's 72, do 180 minus 72 minus 72, because all these things have to add up to 180, and you'll get your final angle, which is 36 degrees. Okay, so that's all we've got for this lesson. Extras in here, so you can see the Pythagorean theorem here. I kind of mentioned this. The reason I thought of this is because the image that I used refers to the theorem as Pythagoras. That's actually the name of the person who came up with the Pythagorean. Well, that's maybe not exactly right. A lot of these historical facts are kind of like that. So that's the name of the person associated with this theorem. Did that person come up with it? Maybe, maybe not. But in any case, it's kind of neat to be that person and have something so useful and universally used attached to your name about 2,500 years after you die, which is especially not bad if you are a cult leader who maybe killed a guy. So actually, if you're interested in that, Pythagoras was an interesting person to say the least. So you can watch that video if you have any interest. Okay, so please make sure you do these questions. They're going to help you prepare. And you got one last test. We got the weekend and your exams on Monday. So again, almost there. That's it.